6th grade, Module 5, Lesson 6 problem set. Number 1. Below is a drawing of a wall that is to be covered with either wallpaper or paint. The wall is 8 feet high and 16 feet wide. Okay, so I'm going to start labeling these measurements on the diagram since they're not labeled themselves. So they're 8 feet high and 16 feet wide. The window, mirror, and fireplace are not to be painted or papered. The window measures 18 inches wide and 14 feet high. So I'm going to say that's 18 inches, and this is 14 feet. I'm noticing here, though, that this is inches, everything else is in feet so far, so we're going to have to deal with that. The fireplace is 5 feet wide and 3 feet high, so 5 feet by 3 feet for the fireplace, and the mirror above the fireplace is 4 feet wide and 2 feet high. So this is 4 feet by 2 feet. A says, how many square feet of wallpaper are needed to cover the wall? Okay, so I'm going to start by, everything's in feet. I'm going to start by changing 18 inches into feet. So remember that there are 12 inches equals 1 foot. So if I have 18 inches, if I do 18 inches divided by 12 inches in a foot, I get 1.5 feet. So I'm going to actually take this and change it into 1.5 feet. So now everything is in the same unit. Okay, so let's start with the entire wall. And then I'm going to take out the other pieces. So the entire wall is 16 feet by 8 feet. So let's do 16 by 8. Is 128 feet squared for the entire wall, but we're not including the window, the mirror, or the fireplace. So the window is 14 feet by 1.5 feet. So 14 times 1.5 would be equal to, let's see, 14 times 1 is 14. 14 times a half is 7. So 14 plus 7 would be 21 feet squared. The mirror is 4 feet by 2 feet, so that would be 8 feet squared. And the fireplace, 5 feet by 3 feet, is 15 feet squared. So together, what we're not using would be 21 feet squared plus the 8 feet squared plus the 15 feet squared. So let's add all of those together. I'll do 21 plus 15 plus 8 gives us 44 feet squared. So that is what we're taking out. So I'm going to take all of this out of the wall. That is, remember we want to find the area of the yellow part. So the whole thing was 128. If I take out the green parts, do 128 minus all the green part was 44. I am left with 84 feet squared. So we need 84 feet squared of wallpaper to cover the entire wall. Okay, so B says the wallpaper is sold in rolls that are 18 inches by 33 feet long. Rolls of solid color wallpaper will be used so patterns do not have to match up. What is the area of one roll of wallpaper? Okay, so since our first answer was in feet, I'm going to go ahead and transfer this into feet. So remember, 18 inches was equal to 1.5 feet. So if I were to find the area of one roll of wallpaper, 18 inches was 1.5 feet, so 1 would be 1.5 feet by 33 feet. So let's do 1.5, I'll make that an improper fraction. 3 halves times 33 over 1, if we make that into a fraction. 3 times 33 is 99 over 2. And 99 divided by 2 would be equal to, well, 100 divided by 2 is 50. So 99 divided by 2 would be 49.5 feet squared for one roll of wallpaper. So one roll of wallpaper is 49.5 feet squared. How many rolls would be needed to cover the wall? So remember, we needed 84 feet to cover the wall. If one roll is 49.5, then 2 rolls would be, if we multiplied that by 2, we get 99. It's just reversing what we did there. So that would be enough because we only need 84 feet squared. So we would need to buy 2 rolls to cover the wall. 2 rolls, or 99 feet squared, to cover the wall. To cover the 84 foot square wall. C. This week, the rolls of wallpaper on sale for $11.99 a roll. Find the cost of covering the wall of wallpaper. So $11.99 a roll, we said we needed 2. So let's do $11.99 times 2. 9 times 2 is 18. 9 times 2 is 18, plus 1 is 19. 2 times 1 is 2, plus 1 is 3, and 2 times 1 is 2. There are 2 digits behind the decimal point, so I'll move it over 2 places. We get $23.98, or $23.98 for the 2 rolls of wallpaper. D. A gallon of special textured paint covers 200 square feet and is on sale for $22.99 a gallon. The wall needs to be painted twice, so the wall needs 2 coats of paint. Find the cost of using paint to cover the wall. So we need to paint it twice. So the 84 square feet that we had, we need to paint that twice. So I'm just going to do 84 times 2 to figure out how much we're going to have to cover. So we have 168 square feet that we're going to need to paint. So that's enough to cover it twice. And it says that the textured paint covers 200 square feet. So how many are we going to need to buy? Well, we only need to cover 168 square feet. So the 200 square feet would be enough. So we only need to buy 1, which would be great. So let's say find the cost of using paint to cover the wall. So in that case, if we use that, it would only be 1 gallon. So let's say 1 gallon is enough. So it would cost $22.99. All right, on to number 2. A classroom has a length of 30 feet and a width of 20 feet. The flooring is to be replaced by tiles. If each tile has a length of 36 inches and a width of 24 inches, how many tiles are needed to cover the classroom floor? Okay, so we have a classroom that's 30 feet by 20 feet, which it's the total area. So 30 by 20 would be 3 times 2 is 6, plus 2 zeros, 600 feet squared. So the whole area is 600 feet squared. Then it says that each tile has 36 inches by 24 inches. So let's convert those into feet. So 36 inches, there's 12 inches in a foot. So 36 divided by 12, that would be 3 feet. And the other one was 24 inches. That divided by 12 would be 2 feet. So each tile is 3 feet by 2 feet. So 3 feet by 2 feet is equal to 6 feet squared. So we have a total of 600 square feet, and we're going to cover it with 6-foot square tiles. So what I'm going to do is just do 600 and divide it by the 6. And 600 divided by 6 is 100. So we would need 100 tiles to cover the area of, what's that, the classroom. So we need 100 tiles. Number 3, challenge. Assume that the tiles from problem 2 are unavailable. So I guess those are sold out. No other designs available, but the tiles are square, 18 inches on one side. So 18 inches is 1.5 feet. And it's a square, so 1.5 feet by 1.5 feet. If these are to be installed, how many must be ordered? So 1.5 feet by 1.5 feet. I'm going to make that 3 halves times 3 halves is equal to 9/4 or 2 1/4. So each one is 2 1/4 square feet. The size of the classroom didn't change, so 600 square feet. That's still the size of the classroom, but now we need to break it into 2 1/4 foot squares. So I'm going to do 600 divided by 2 1/4. And if you remember how we learned to divide fractions, we can flip and multiply. So 600, I'm going to take the second number, so 2 1/4, I'm going to make that back into 9/4 so that I can flip it and multiply. So times 4 over 9. I'll make that 600 over 1 to make that a fraction 2. So 600 times 4 is 2,400 ninths, and now I'm just going to do 2,400 divided by 9. So 9 can't go into 2, but it goes into 24 twice, so minus 18. 24 minus 18 is 6, bring down the 0. 9 goes into 60. Let's see, 9 times 5 is 45, 9 times 6 will be 54, so bring 6, bring down a 0. 9 goes into 60 again, 6 times. And there's nothing to bring down, and since I was already working with fractions, I'll just make this we have 6 left over out of the 9. So 266 6/9 can be reduced to 2/3. So we would need 266 2/3 tiles, but you can't buy 2/3 of tile, so I'm just going to say we need 267 tiles to cover the entire area here. Number 4, a rectangular flower bed measures 10 meters by 6 meters. It has a path 2 meters wide around it. Find the area of the path. All right, so they've given us the area of this flower bed. So the middle part is 6 meters by 10 meters. So the area of that middle part would be 60 meters squared. So now what I want to do is find the area of the whole outside part, so the larger rectangle. And I know that it's 2 meters wide everywhere. So this is 2 meters wide, so an extra 2 meters there. So all the way across is 14 meters. And then this would be an extra 2 meters, and this is an extra 2 meters. So that part is 10 meters. So if I found the huge rectangle all the way around would be 10 meters by 14 meters, or 140 meters squared. So if we want to know the area of just this path along the outside, I'm going to take the whole area of the big rectangle and subtract the small rectangle. So 140 minus 60 would give us 80 meters squared is the area of the path. Number 5, a diagram of Tracy's desk is shown below, shaded in blue. He wants to cover the missing portion of his desk with soil in order to grow a garden. Find the area of the missing portion of the deck. Write the expression and evaluate it. All right, so we want to find the area of this right here. So we have the deck. There's a missing part. So I'm going to, let's see, this part, the height is 2 meters, and the length here, let's see, I know to here, that is, I know this whole part is 7 meters, and this little part is 1 meter, which would make this 6 meters. So the area of it would be 6 meters by 2 meters, or 12 meters squared. All right, find B. Find the missing portion of the deck using a different method. Write the expression and evaluate it. Okay, so we have to solve it a different way. So I'm going to find the area of the whole thing, and then I will subtract the other pieces from it. So let's do the area of the entire rectangle. So 8 meters by 1 meter and 5 meters would be 6 meters. So let's do 8 meters times 6 meters. And then from there, what we're going to do is subtract the other pieces that we don't want. So we don't want this rectangle. And that is 5 meters by 1 meter. And we also don't want this rectangle, which is 1 meter by 8 meter. And we also don't want this rectangle, which is 1 meter by 2 meter. And then we also don't want this bigger rectangle, which is 7 meters by 3 meters. So it's a long expression. So let's calculate what all of that is. So we have 8 meters by 4 meters would be 48 meters squared, minus 5 meters by 1 meter would be 5 meters squared, minus, that would be 8 meters squared, minus 2 meters squared, minus 21 meters squared. All right, so let's do, I'm going to take all of these and add them together so that I can just subtract them as one. So we got 5 and 8 would be 13, and 2 is 15, so 21 plus 15 would give us 36. So we have 48 meters squared minus 36 meters squared. That'll give us 12 meters squared, which, great news, it is the same thing that we got in part A, which is the point. They wanted us to just show a different method. C, write 2 equivalent expressions that can be used to determine the area of the missing portion of the deck. So, right, we already did that. So write this. So there's one. Another one was just this. 6 meters times 2 meters. So there are 2 equivalent expressions that'll get you the same answer. So that's C. And D, explain how each expression demonstrates a different understanding of the diagram. So one expression, the first expression, shows the dimensions of this interior part. So let's say one expression shows the dimensions of the interior rectangle. And the other one shows the total area minus the sum of the wooden areas. Okay, and number 6. The entire large rectangle below has an area of 3.5 feet squared. So this whole rectangle is 3.5 feet squared. If the dimensions of the white rectangle are as shown below, write and solve an equation to find the area A of the shaded region. So we just want to know the shaded region. So we're going to take, and they already gave us the area of the whole thing, which is nice. So 3/4 times 3/8 would give us 9. 4 times 8 is 30 seconds. So now we just need to take that 9 30-seconds and take it away from the entire large rectangle. So 3.5 minus 9 30-seconds. So now it's just a fraction subtraction problem. So let's find a common denominator. That would be 32. 1/2 is equal to how many 30 seconds? 2 times 15 is 30, so 2 times 16 would be 32. So we have 3 and 16 30 seconds minus 9 30 seconds. So 16 30 seconds minus 9 30 seconds would be 7 30 seconds. And we're just going to bring down the 3. So we get 3 and 7 30 seconds feet squared as the area of the shaded part around the outside.